Assalamualaikum. I am Computer Asif Mahmood. My ID is 024 222 510 Today I am going to give a presentation about real-life application of Laplace transform in solving ODEs. Now, what is Laplace transform? Laplace transform is a mathematical method used to transform functions from time domain to frequency domain. It converts differential equations into algebraic equations. It makes complex problems easier to solve. Here's its formula. Laplace of function of t is equal to function of s. It's widely used in engineering, physics, and applied mathematics. Then why do we need it? Its differential equations are difficult to solve directly. Laplace transform simplifies the solving process, converts derivatives into algebraic terms. It easily incorporates initial conditions. It also reduces time and computational complexity. Now I am discuss about some fields of its application. First one is electrical engineering. Here it analyzes the circuit. Then the mechanical engineering. Here it analyzes the motion and vibration systems. Then the control systems. Here it relates with automation and robotics. Then the signal processing. Here it's used in communication and filtering. It helps engineers design, analyze, and optimize systems. Now I am going to discuss some applications. First one is electrical circuits. Here it used in analysis of RLC circuits like resistor, inductor, and capacitor. It helps determine voltage and current over time. It converts circuit differential equations into algebraic form. Here important is that power systems, electronic design, and communication devices. Now I am going to discuss an application called mechanical systems. Here it's used in modeling spring mass damper systems. It helps analyze vibration and motion behavior. It also determines system response to external forces. Here are some real-life examples like car suspension systems, shock absorbers, and machinery vibration control. Now I will discuss application called control systems. Here it used in designing automatic control systems. It helps analyze the system stability and performance. It converts system equation into transfer functions. Here are some applications include robotics, industrial automation, and aircraft and vehicle control system. Here is an example of solving ODE. Here is the given equation. To solve this, here are some steps like apply Laplace transform, then convert into algebraic equation, then solve for y of s, then apply inverse Laplace transform to get y of t. It simplifies complex differential equation solving. Now I am going to discuss the advantages of Laplace transform. It simplifies complex mathematical problems. It converts differential equations into algebraic equations. It handles initial conditions easily. It also saves time and effort. it is applicable to real-world engineering systems. Then the conclusion. In conclusion, we said that Laplace transform is a powerful tool in engineering mathematics. It's widely used in electrical, mechanical, and control systems. It simplifies analysis of real-life problems. It bridges the gap between mathematics and engineering application. That's all. Thanks for watching my presentation.